Hello, everyone. Welcome to the Carolina Weather Group. We're happy to have you this evening. We're going to be talking space with our good friend Tony Rice, NASA ambassador, also a contributor for WRAL in Raleigh. So Tony is our resident person that we go to, and we have space questions. There's some really cool things going on with this Mars launch. We also have some Loon balloons. You may have seen some pictures floating around on social media over the last couple of days or weeks, and we're going to talk a little bit about that as well throughout the program. But Tony, we have this mission. I think originally this Mars mission was scheduled to go off June 20th, right around that date. It's since then been pushed back a few days. So can you tell us a bit about the mission itself? Well, what are we trying to accomplish as we head off to Mars?
So this is was originally called the Mars 2020 rover, and it's a follow-on to the Mars rover you would know as Curiosity. So it's about the size of a minivan, a little bit smaller than that, and its purpose is to go out there and find basically what happened to Mars. It's going to work in concert with obviously Curiosity and all the other assets that are out there at Mars, the orbiters that are studying the atmosphere, that are taking those fantastic pictures that we see of Mars. But it's a very similar rover to Curiosity. It's using the same spacecraft bus. And that's the body of the spacecraft, the wheels, the mobility system, all the computers, all the communication systems. But the real exciting thing about these spacecraft and about these missions are the instruments. So I think of this as like Curiosity 2.0. It has a lot of some of the same instruments that Curiosity did, but they've been upgraded. They've got a little more capability to them. We've learned a lot as we've had Curiosity on the surface of Mars for so many years. We've also added a couple of new ones. I'm sure we'll get into some of the more exciting ones there, but the ones I know that the one instrument, my favorite one, that I know is going to be your favorite as well, is called MEDA, and it stands for Mars Environmental Dynamics Analyzer. And I'm really looking forward to MEDA getting on the surface of Mars. It's about a 12-pound instrument. It's chewing up a whole 17 watts of power. You have to really budget your power up there. Curiosity and this new 2020 rover are going to both be both powered by a nuclear power source. We don't have to worry about any of the solar panels getting covered in all that Martian dust and causing us problems there. But the deal with MEDA is it's going to be capturing information about air temperature, ground temperature, radiation. We've got a dust sensor that's on there as well, so we can help study those dust storms. If you saw The Martian with Matt Damon, did a pretty good job of showing what dust storms can be like there. The beginning of the movie was a little fantastic, and we don't quite get wind speeds like that, or at least we don't have enough volume in the atmosphere to produce some of the things they're talking about there. We're going to put relative humidity. We're going to be able to measure that as well. There's a thermal infrared sensor on there, and there's wind sensors as well. And the wind sensors are kind of interesting. There is wind on Mars. We're getting information about winds from another mission that is on the surface of Mars right now called InSight. It is not a rover. It is a lander, so it stays stationary. It can measure what atmosphere comes to it and the column of air above it. So we are seeing winds there that are a little bit higher speed than we expected. You wouldn't be able to feel them though, because the volume of air there is so little.
So Tony, there's this new device that's coming with Perseverance that I literally just found about in the last 5 minutes. So it's going to be some type of helicopter drone deployment. Tell us about that and how that works in an atmosphere that's a lot thinner than ours.
Yeah, that's going to be the really interesting thing, is how you get lift in such a thin atmosphere. The Mars atmosphere is about 1/100th that of Earth's. So it's very, very, very thin. Sorry, not 100th, 1,000th that of Earth's. Very, very thin. But the drone itself, the helicopter itself, has pretty wide blades, and it's going to be spinning really, really, really fast. So don't think drone like the drones that we know here on Earth. It's not going to be sitting up there and hovering for a good amount of time. It's going to take hops. And its purpose, number one, is a technology demonstrator. It'll be the first time we've ever flown on another planet. That's pretty exciting unto itself. But it's not just a technology demonstrator. It's going to be providing valuable information to the team that is driving this rover. And yes, there are rover drivers. They sit in California. They're sitting at home right now because they're able to VPN in and talk to the rover that way. But their technical term or their technical title is rover planners, because they're doing exactly that. They're planning what drives need to occur during that day to put the rover in a position to do the science. So this helicopter is going to help out with that a little bit. It's mounted on the underside of the rover, so after the rover lands and everything's checked out, the rover will deploy the helicopter, we'll drive off of it, and then we'll be able to take the helicopter off and move it about. It's going to serve as a form of scout for the geologist. It's going to help us move ahead and make some good decisions about where to move the rover to in order to do some good science.
Now, Tony, I have a question as far as, like, I've always wondered the signal, right? So these are being operated remote control a lot of the times. So I know there's some automated processes on site that the rovers would do to correct maybe a rock in the way or something. But how long does the signal take to get to the rover as you're steering it? Now, the radio waves travel at the same speed of light, or I mean, what's the difference in
right at light speed?
How much time?
So it varies throughout our year and the Mars year. Mars year is roughly about 18 months. So it's anywhere from about 10 minutes to more than 30 minutes. So when I mentioned somebody that's driving the rover, you might have this picture in your head of a steering wheel and a gas and a brake. Absolutely not that. It's sending commands for the rover to act on at a later date.
Another function of this robot is that it's going to be collecting samples on the surface and to be later taken back to Earth and studied here. How will that work? How's it going to get back to Earth?
To be determined. So there is going to be a caching capability where samples that are first studied by Curiosity are going to be packaged in a way that they can be picked up at a later date and brought back to Earth. We're not quite ready to put boots on Mars yet. That's a goal, but it's a goal that's pretty far into the future. As a step between now and putting boots on Mars, a robotic mission that could pick up those cache samples and bring them back. Why not just go and pick up random samples and bring them back? Why bring these that have been studied by the Perseverance rover, by the 2020 rover, to be able to do additional study on something that's already been studied by a robot is just going to give us a ton of information that we can apply to other studies that have been going on there for years and years. I mean, on back into the Viking days, back in the 70s. So that's why it's being done that way. How it's actually going to happen, there's a lot of different ideas about that. One of the biggest challenges there is how you have enough energy to launch from Mars and get back to Earth. How do you do that? And there's different theories on how that might happen. Do you bring enough fuel with you to be able to get back? Do you use the Martian soil as a source for energy and construct fuel that way? Lots of different ideas. It's being worked on, but step one is to gather those samples and leave them behind so that they can be returned.
In our relentless pursuit for life on other planets, we look at water and the potential for water. We've seen pictures of icing on the poles, a type of icing, not as we would know it, but what is the evidence for water on Mars, and maybe some of the past evidence that shows you there could have been water flowing? Has there been anything presented in some of the latest information?
Yeah, that's a great question. And the icing that you're seeing on the poles happens every Martian winter. And you can actually see it with a backyard telescope if you look at the right time. We see it on both the North and the South Pole. What you're seeing there is actually CO2 ice. It's actually carbon dioxide. And the poles get, those ice caps on the poles, they get larger and they get smaller according to the season. And we can see that in Curiosity's air pressure sensors. As that carbon dioxide transfers from a solid phase into a gas phase, it adds to the atmosphere. And we'll see atmospheric pressure go up during the summer months, and then it precipitates down, actually snows, dry ice on the poles during the winter months when it gets colder. Mars has seasons because it has an axial tilt, just as Earth has an axial tilt. It's very, very similar. But as far as evidence for water is concerned, it's really in the geology. The geology is, it tells us the story of what happened in the past on Mars. Where we landed Curiosity was an area that was formerly the bottom of a large river system. It was at the bottom of an alluvial fan, and that's kind of a funnel-shaped pattern. If you've ever seen satellite photos, color satellite photos of the Mississippi River Delta as it dumps out into the Gulf of Mexico, you see that triangle. That's all that sediment that's been collected up along the Mississippi River. Well, that's the Martian version of, or we landed on the Martian version of that. It's all dry there now. We're not seeing evidence of liquid water, but we're seeing the geologic evidence of it. So one of the very first photos that came back from Curiosity after it landed was of these rounded pebbles. Well, those don't form round. Those are rounded as a part of a water process that's picking up and moving them along and rounding them off. And we found lots and lots of that. So through study of the geology and the chemistry of those rocks as well, that's what told us that it was fresh water, determined that the area that Curiosity landed in was probably about knee-deep in water a couple million years ago. The idea that Mars was once a very different place and a lot wetter and perhaps a lot greener, that is one of the things that Curiosity found pretty quickly after its landing time.
Tony, looking at some of the points here for the mission, two of them kind of really piqued my interest. It says this is the first leg of a round trip to Mars, and then after that it's also talking about how this could actually pave the way for future human missions to the moon and to Mars. Can you tell us a little bit about that?
Well, every time we put something on another planet, we learn a lot about it. And the road to putting boots on Mars, it's a long one. But even what we're planning on doing around the moon, coming up with the Artemis mission, is going to teach us a lot about that. Being able to live potentially off some of the resources on the moon will teach us a lot about that. We got to really understand the chemistry and the makeup of the Martian surface to be able to have people live there.
I think that's really interesting. We've always heard about people going to Mars, but this actually could be some small steps for that. And also seeing there's going to be like 19 cameras on this that we're going to be able to kind of follow along with the mission.
Yeah, there's a bunch of HD cameras on Curiosity. We got even more on Perseverance. And I mentioned the name a couple of times. I need to tell you the story about Perseverance. So for the longest time, it was called the Mars 2020 rover. NASA's really terrible at naming things. You give NASA engineers and scientists the opportunity to name something, and they're going to give it an acronym. They're going to give it something boring. Maybe it'll be a backronym that actually spells something that you can pronounce. But the cool names, those always come from the kids. So Curiosity was named by a little girl in Iowa, who by the time it launched, she was a lot older than that. She actually went on to be, I believe, an environmental scientist. So she got a lot out of that experience. Perseverance was named by a young man up in Northern Virginia, and I was on the team that helped review a lot of the submissions that came in. They had to come up with a name, and they had to come up with a couple of paragraphs about why they chose that. And I can't recall if I read so many of them. I can't recall if Perseverance was among that. But some of the ones I read were pretty out there. I'm glad they picked Perseverance. We tend to call it Percy. So if you hear talking about the Percy rover, that's what we're talking about.
Speaking of Mars, I know you run a Mars weather page on Twitter. I know you kind of keep up with some of the stuff, so we thought it'd be kind of cool to tie in Mars weather, your Twitter page. What all you monitor? How do you get that information? How do you provide Mars weather forecast and observations?
So we don't forecast yet. We're hoping to have enough data here one day that we can start having a forecasting product. We'll certainly need something like that once we get those boots on Mars. But right now it focuses on the InSight mission. It's pulling data down close to daily. There's a lot of data that has to come down, and unfortunately the weather data sometimes gets pushed to the back if there's images or things like that that the science team needs right away, especially when we were working with InSight trying to get a temperature probe to finally be pushed into the Martian soil there. I think everybody that's ever put a spade into the ground in the Carolinas knows what that clay's like. So it was dealing with some of that same problem up on Mars. Those images that were helping them understand that problem, those took precedent. But anyway, we do see data come down from InSight, and that is delivered through the same mechanism that all those pictures are delivered through. It's called the Deep Space Network. Generally, most of these, both the rovers and this InSight mission, have the ability to communicate straight back to Earth, but they don't tend to do that. They tend to upload the images and other data every time an orbiter goes over. And that orbiter acts like a router and store and forward that information once it sees Earth again. It's a little faster that way, and there's a little more bandwidth. But we see that data come down. I know she just popped that up. So we see temperature data. We see air pressure. I find air pressure to be some of the most interesting there. And then we see wind data as well. So the last one that came up was from Sol 566, and a Sol is a day on Mars, and that equates back to the 29th of June. It's the last time we saw something from it. As you can see there, the low was 25, I'm sorry, the high was 25, the low was 126 below zero, and these are both Fahrenheit. And each day on this Mars weather Twitter, it goes and randomly picks a city somewhere, and Clayton just happened to be picked up there last time it was doing a comparison. So you can see the comparison there. But again, the most interesting comparison in my mind is the pressure. So, we were seeing about 1,012 hectopascals, which I think equates to millibars. You guys keep me honest there. That's what y'all speak in. Yes. And that on Mars is about 7.7 hectopascals. That's one of our biggest challenges on Mars, is the lack of atmosphere. It's just really, really, really thin there, and it continues to be stripped away by the solar winds. And that's not something that we're going to be able to correct anytime soon, perhaps ever.
So I guess there's really no wind chill there. I mean, I'm looking 25 degrees with 37 mile per hour wind gusts. That's not really a wind chill there then.
Yeah, not too bad. We do see temperatures go above freezing there. It does happen.
Yeah. So Tony, I mean, obviously you're not using tri-cup anemometers or RM Youngs. I mean, how is this? How is wind speed capture? Is it using like Venturi effect, or you're consolidating the air into a point, or how is that measured exactly?
So the thing to look up is an instrument called a hot dice. It is a couple of basically electrodes that are exposed out there and are measuring differentials. They are without moving parts. That's really, really important when you've got a robot out there that you can't go service. There is no Home Depot on Mars to go get spare parts.
Well, you said one last thing. You kind of mentioned that it does get above freezing on Mars. I wonder if you could just real briefly speak to the general temperature range. How cold does it get in winter? How warm does it get in summer?
Yeah, we're talking around -200 Fahrenheit with the lows. And during the summer, most of the time we're talking in the average temperature there is hovering around -80, -100.
I just think it's cool. I just think it's cool you have a mesonet on Mars.
We do. We got 2 of them now, about to put a 3rd.
I've heard that there's a team already being picked to possibly go to Mars by as late as, 2028 or 2030? Is that correct?
I will make no comments on when we're going to Mars. You're not going to trick me into that.
I had to try.
There's a lot that needs to be done, and each one of these missions, be they robotic or be they human up to the International Space Station, or once we get Artemis off the ground and have a gateway to the moon, each one of those, it may not seem like it's getting us closer to Mars, but we learn something from each one of them that can be applicable. And when that actually happens, I hope it happens soon, but it's a long road.
Tony, shifting gears, one of the things that I spotted on Flight Tracker this week, and I think several of the people here in the Carolinas have, were alongside all of the little cute icons for airplanes, these circular balloon icons for the Loon Balloon project. Tell us about it. I understand you're familiar with it, and I think it caught a lot of us flight trackers off guard maybe a little bit, but also people screaming UFOs in the sky as these things were passing overhead.
Yeah, there was a little bit of that, wasn't there? Yeah, it's something that I got to learn a little bit about the other night. So in addition to talking with you fine folks, I've got about 350 meteorologists around the country that I'm in contact with on a regular basis. I try to give them information about the what's visible in the sky, usually planets, usually comets, meteor showers, things like that. But I am perfectly happy to get a what's this thing in the sky question when it's something in our atmosphere. And that's what happened. I forget what day was it. Was it Tuesday night?
Yeah, that sounds maybe Monday. I mean, depending on where you were, right? These things went right over Greensboro, down towards Fayetteville, then out towards Charleston. So it was kind of a small day.
I first got looking at these things. It was Tim Buckley at WFMY in Greensboro. I get a text from him and it says, "There's this white dot in the sky. What do you know about it?" What? And I looked at it and immediately thought it was a balloon. Unmoving white dot in the sky, especially that high up, is going to tend to be a balloon. It's so high up it doesn't appear to be moving at all. And these balloons are operating with between 50,000 and 60,000 feet. So as you mentioned, as part of Project Loon, we came to understand, which is a project that is, I want to make sure I get the relationship correct here. Google and Loon are subsidiaries of the same parent company, which is called Alphabet.
Okay.
It's all business spin-off nonsense, but anyway, they're looking to provide, as I understand it, internet connectivity in areas that don't get it, which I think is great. I think they're pushing to have like 1 megabit capability. There's an antenna that you have to have outside, and it's going to be a network of balloons, not unlike SpaceX's Starlink project, that talk to each other and serve as an uplink downlink network. But as I understand it, they're in a testing phase. I think their launch site is up in northern Arizona somewhere. I'm sorry, northern Nevada. And these particular balloons that floated over the Carolinas, there was 4 that were visible here around the Triangle area, and up in the Triad around Greensboro, they were visible there as well. If you think about 50,000 feet, and you think about that circle that you draw around something like that, it's visible for a good amount of space. So we dug into it. It's funny that you saw it on flight radar first, because everybody else saw it in the sky first. We go outside from time to time.
We didn't get the direct overhead pass here in Charlotte.
Yeah, you did have one float a little bit near you. There was one that went on out over Asheboro and Asheville, out over Cherokee, and ended up in Alabama the last time I saw it. But the ones that we saw around Greensboro, as I understand them, they floated out directly south off the coast of Charleston and ultimately Jacksonville. But I went and looked just out of curiosity. Once I found out that they were trackable through flight radar, wrote a little script that went up to use one of the APIs of one of those radar tracking sites, or those flight tracking sites. I found 32 of them around the world.
Wow.
I found actually 33 over Australia, the Congo, Kenya, Zambia, Peru. I'm looking at my list here right now. There's a bunch out east of Madagascar and one off Peru. And then we had the couple here that had floated down from Canada, down across Ohio, West Virginia, and into the Carolinas.
They could be pretty scary if you don't know what they are. I had one other question, and then it sounds like Shay has one too. I'm curious, Tony, in your reading, besides the application of using them to provide internet to rural places that maybe aren't tethered on the ground, have you seen any discussion of an application to use them in storm response when a network might be wiped out due to a natural disaster? I
believe they actually used them for that purpose. after, I want to say it was in 2017, but with that pair of storms that went over Puerto Rico. They did some releases from Puerto Rico. If you go on one of the flight tracking websites, I think it might have been Flight Radar 24, don't quote me on that, but there's a blog post on there about them tracking many of these things during some of those storm responses, and providing that kind of connectivity to folks that, you know, they may not have power, but they probably have a way to charge phones. To figure out how to do that, it takes a little while to get that infrastructure back up for cellular service. So being able to do that with a balloon is pretty incredible.
Yeah, I would agree with that, Tony. I know that some of our Mets with WeatherFlow, we met and talked about it several years ago when Google was partnering with them. Now they're partnered with HAPS Mobile, and they provide LTE connectivity to these countries, these third world countries. There are other countries that lose connectivity during natural disasters. Peru, 2019 was a prime example of where Project Loom was utilized to get LTE connectivity for authorities to get their internet settings back up, and for folks to get some LTE receptions on their phones and whatnot. So it's pretty interesting. I didn't know that there were that many balloons, but I know that they started this off back in 2013, where they did their first test flight around the world. So things have kind of progressed over time. Do you see this as being a permanent solution?
I don't know. Not my area of expertise, but I think it's great that we're able to provide that kind of functionality there. One concern I've got, though, is that these things are helium-based. And helium is something that is in short supply right now. I mean, if you were to go to one of the party stores and try to get helium balloons, you probably couldn't do it. Helium is a very important gas in the space industry. It's used for cleanly purging cylinders and spheres and things like that. So we need it for lots of different things. I hope they can find another lifting gas other than helium, because it is a neat and useful project. But I hope they don't use up too much helium doing it. One other thought on it too is, while we're up there hanging around for days and days at a time at 50, 60,000 feet, sure would be nice to get some weather instruments up there too, some atmospheric instruments, and be able to send some of that data down from that close to the stratosphere.
Sure, I know Boeing's doing that with the unmanned craft that flies for weeks and months at a time on solar energy. And I think when I read on Loon's website that they have their partnership with HAPS Mobile, they have test flight. They've done all their they've rolled out their new unmanned craft that goes out. So that may be the solution to what they're looking for. Instead of having balloons anymore, they're going to have unmanned planes going up that just circle around.
We've lost a lot of data from the grounding of commercial airliners too during the COVID situation. It's amazing how much data we were getting from those. That's closer to 30,000 feet, but it really filled in a lot of those gaps the radio sondes were providing.
In the past, we've talked about the radio sondes that you just mentioned. Could you maybe compare and contrast these Loon balloons with a typical weather balloon, because they have very different lifetimes, obviously, and different purposes?
Different lifetimes, quite a bit larger, and if you find the images of the Loon launch site, I was looking at that the other day. They got some permanent structures out there, and they're building some larger ones as well, just to be able to handle launching these things, because they are so significantly large. And they do get much bigger as they go up into the atmosphere and the air pressure goes down. So most folks that I saw report them or share pictures of them describe them as looking like big jellyfish. It's a kind of a silvery looking material, very, very large. It's not as spherical as a weather balloon looks. Those are, you guys are the experts here. I think they're made of some sort of a latex material, but it's very opaque. Where these are almost like translucent appearance. They're much, much larger, and the volume of lifting gases that they put in there is very, very different too.
So the Loons don't explode at 70,000, or they aren't even meant necessarily to go up to 100,000 feet like a typical weather balloon.
They aren't. They hang out between 50,000 to 60,000 feet. I think a lot of what the research is doing right now is to understand how the steering winds up there work, how viable this is to provide, how wide a coverage that they can provide, how the jet stream changes in the jet stream and other things like that are going to affect their coverage. It'll be interesting to see what comes out of it. And as you mentioned, we can go on these flight tracking websites and look at them. If you go in and you enter HBAL and a 3-digit number, you might just find one.
Well, Tony, we certainly appreciate you being with us tonight to talk about the Mars mission and the Loon Balloons, and we definitely appreciate your time. If folks want to follow you again on Twitter, how can they do that?
So my personal account is RTP Hokie, Hokie, and if you are interested in Mars weather, the Mars WX report.
You can also find you on WRAL as a contributor and the Weather Brains, right? You're still doing the recorded version?
Still doing the recorded version. It's every Monday night we're putting that out, and I try to put something different out every week that's usually space related. Every once in a while we'll add in some other weathery stuff in there too.
Well, Tony, we certainly appreciate your time, and if you're watching tonight and you want to know more about the Mars launch, we'll probably be airing those towards the end of the month as we get into with our friends at NASA TV. I'm sure we'll be doing some more events surrounded by that mission and that launch. So stay tuned with that. And we appreciate you watching the Carolina Weather Group. Until next time, we hope you have a great evening. And we'll see you on the next Carolina Weather Group episode.